Welcome back, viewers. Uh, Last class, you saw the beginning of circular motion, but that's pertaining only to kinematics. I made a formal beginning of that, and you have seen, as usual, I request you to subscribe the videos, and anytime you want to watch a video, do not forget to watch my previous videos, because these are all interconnected, right? Fine. Now let us get back. If you just recall, I have tried to give you the fundamentals of circular motion. This is something that most of the people find it difficult to digest. And that's the reason why I've tried to give you a very detailed analysis of that. Now here, let me remind you, I'm not dealing with the circular motion in general, but I'm talking of circular motion kinematics only. There is a reason, because the dynamics of it, as I'm going to discuss, I think, very shortly, then probably I think all these things would be very, very useful to you. And this is what I want. In fact, I just want to give you a recap of what I did in my previous lecture. If you see, I said a particular particle is moving in, a particular particle is moving along a circular path. And if I take this standard directions as I and j, and the particle makes a general angle theta, let me presume that it is moving in this fashion, right, anti-clockwise, and the radius vector is r. So I try to resolve this vector, and then if you recall, this is what I have done, I cos theta plus j sin theta. Now, theta is a variable, is an angular variable, and this is also called angular displacement with particular reference to any standard direction, as you can see now here, right? Now, once I differentiate this, you know that we're going to get cos theta. I have already given you, so you get minus sin theta d theta by dt, which is omega, and this is cos theta omega. Now this is what we have tried to do. This is minus I sin theta plus j cos theta, and the modulus of v is r omega, because its modulus is always 1. Under root of sine square plus cos square is 1, you know very well. Now the same thing with the right hand rule, you can write it as omega cross r. Now most of you get it down. What is the direction of omega? What is the direction of theta? What is the direction of alpha, the angular acceleration? These are all perpendicular to the plane of motion. Always keep this in mind. Always. So right hand thumb rule, if you follow, well, this is the direction of theta and all that. And one very important thing, and if you recall some of my lectures when I spoke about the angular displacement, I said the finite angular displacement cannot be treated as a vector. What was the reason? The reason was very simple, because it would not follow the commutative law of vector addition. That's what I told you. Now, if that's the case, if theta is infinitesimally small, I made a mention of this in my vector lectures. If it is infinitesimally small, then you can treat it as a vector, because it obeys all rules of vector addition. Now, the problem is, if you really think rationally, you should also ask a question to yourself, that if theta finite were not to be a vector, how can finite omega be a vector? how can finite alpha be a vector? You know that omega and theta are related like this. The reason is omega is defined for infinitesimally small displacements only. Therefore, question of this not to be called as a vector doesn't arise. Thank God for this. Therefore, omega, any value is a vector. Alpha, any value is a vector, but theta, any value is not a vector. That's what I want you to really understand, right? So now we have got it as omega cross r. You have seen, and then I try to give you acceleration. Then in this acceleration, when you have tried to divide this into two parts, then you definitely got two terms there. You remember, you got two terms, and one is towards the center, and the other is parallel to the velocity, either along the velocity or opposite to velocity. Now, if you want to write that, I will remember one. When you say it is like this towards, that is a radial acceleration, then minus the radial acceleration is r omega square I cos theta plus j sin theta. Remember, the negative sign indicates it is r cap. Then plus, next is this is along the velocity. Along the velocity, we have already written r alpha minus I sin theta plus j cos theta. This could be plus or minus depending on whether the value is increasing or decreasing. Likewise, you can get. Now, this in fact, this is the normal acceleration, this is the tangential acceleration. Therefore, if you write this as at bar plus this is ar bar. Now, ar bar is like this, at bar is tangential, but both are perpendicular to each other. If I want to keep a new direction, remember, be careful, my ij are fixed, ij's are already given there. Sometimes is what we call as a natural coordinate system. The direction in which the particle is moving itself is one of the axes, and perpendicular in the plane is what we call as a normal axis. Therefore, this, if I keep symbols for this as a t cap, and this is minus r cap. Yeah. Very important. The same thing that you have derived, I am only trying to explain in several ways. Some textbooks give in some way, some textbooks give in a different way, all are right only. But probably in your understanding you may have some difficulty at some stage. So I am trying to give you a clarity on this. This is right, this is right, this is right, all are right. The only thing that you have to understand is this at along this, if it is along the velocity positive, opposite to velocity negative. And but ar is always directed towards the center. AR is always directed towards the center. This is what I tried to explain. And then I went on to tell you this A, that B bar, you have written it as omega cross R, alright? Then A bar, you can write it as alpha cross R plus omega cross R. in all vector notation, this is how you can understand. This is your tangential acceleration. This is your radial acceleration. Is the essence of what I did. And I also said, when do you get AT, AR, etc.? Whenever you have, say, the velocity is increasing likewise, I told you that AT is along the velocity and AR is of course always towards the center at that instant. Therefore, the resultant acceleration makes this is also being velocity an angle less than pi by 2. I think I was trying to mention of this, make a mention of this before. So you could look at that. And then this is while taking a turn, if you try to increase your velocity, this is the scenario that you are going to come across. But on the other hand, in realistic picture, whenever a person tries to take a turn, what he should generally try to do, but that involves dynamics, therefore I'm skipping the discussion. But then this is the AR as usual, and this is the AT. Therefore, your total acceleration makes an angle more than pi by 2 or a choose angle that you could see. Well, this is what I discussed in my previous lecture. The purpose of giving recap of this particular thing in great detail is that you should always remember this. Okay? Right. Now, with this background, now let us look at, just as you have got linear variables, and this is angular variables. The linear variables are all in plane of motion, all perpendicular to plane of motion. What are they? Theta cap, omega cap, alpha cap, etc. Here, what are all they? R bar, B bar, A bar, R bar, AT bar. These are all in the plane. These two are always perpendicular, always. That's what we should remember. Now, what are all the corresponding things? I'll just try to put it here. What we talk of position or displacement is theta bar. What is the relation? Your S bar is theta cross R. Arc length, if you see, you get R theta magnitude. By analogy from E is equal to omega cross R, I have given this relation. In a similar way, velocity, V bar, here omega bar, and V bar is omega cross R. In a similar way, tangential acceleration, the corresponding thing is alpha. So what is AT? One thing you should always remember, I'm writing suffix T here. This means it indicates it is tangential. In one-day motion that we studied, we used only this because this suffix we didn't keep it. Whether this is along the velocity, whether this is opposite to the velocity, or whether it is not present, all are decided only by this. And this alone was what was discussed in linear motion or one-day motion, if you remember. Another thing that we didn't come across before is AR. This U, there is no correspondence here, but AR is equal to, this is what we call as vector triple product. Now, if you take the magnitude, you can write and then find out, no problem at all. But now the additional part I'm going to do now is this. I'm erasing, but I'm continuing the tabular form. What? You have, for example, A is dV by dt, or V is equal to, this is what we already discussed. V is equal to U plus integral dt. In a similar way, you can write here as alpha d omega by dt. So omega is equal to omega naught plus. Look at the correspondence. Absolutely similar, if not the same. Be careful about that. The units are already spoke. Omega radian per second square, and t of course is in seconds. No issue at all. Now this is one. The other one that we can probably write is, I have already described this. Corresponding to this, I can write omega d omega by d theta. Look at the correspondence. And here if I write v square is u square plus 2 integral a dr. In a similar way, omega square is omega naught square alpha d theta. I hope you are not finding any difficulty anywhere in this. Okay? So you can directly use this. And the other one is S is integral, say, v dt. How do you write here? Theta is equal to integral omega dt. And you can, if it, A is a constant quantity, if for A equal to constant, S is ut plus half at square. For alpha constant, theta is equal to omega naught a plus half alpha t square. The corresponding equations I am putting it over there. In fact, I need not have to discuss any example. All the examples that I have discussed there are applicable here. Okay? Now, you remember, for A constant, you have written A by 2 into 2n minus 1. Theta n is equal to omega naught plus alpha by 2 into 2n minus 1. Same way, A constant, here alpha constant. Okay? This is how we look at the, I'm not going deep into the dynamics part of it at this stage, but I want you to understand how these are worked out as far as only kinematics are concerned. That's it. Every example that I discuss for a variable alpha and for a constant alpha, they are valid for variable A and constant A. Only difference is the what? What is the difference between the two? Units. Be careful about the units part of it. Alright? Now, let me tell you that a particle is in circular motion. Okay? Now, if it undergoes an angular displacement theta, Suppose if I ask you, you know that this is R, this is R. This is the very original position. This is the final position. If you are asked to find out what is the displacement of the particle, what do? Final position towards initial position. How do you get the length of this? This is an isosceles triangle, third side of an isosceles triangle, 2r sine theta by 2. This is the displacement. Now, what is the distance from here till here? R theta. If this undergoes 1, 2 pi r. If it undergoes 2 revolutions, you will write 4 pi r. N revolutions, then you write 2 pi n r. Likewise, any number of such things you can keep on adding to this. Okay? Right. Now, okay. Then is the next part. For example, this is how the particle is moving. This is your center, maybe A, this is B, the B, let us say, it has gone to C. Now, let me call this as O. Now, if I ask you, let the angular velocity of this particle with respect to C is, let us say, omega. Or I would say, omega C is omega. Now, this is a ticklish issue. See, you talk of omega, you talk of velocity linear. Linear velocity we always refer to with respect to any reference frame. In a similar way, I can fix a point or axis for even angular velocity. If I take with respect to C, I know this is going with omega, no issues at all for you. What do? If I take this as a point, this is the one. What you should try to do? The perpendicular to this radius vector, the velocity you have to do with respect to C. Now, when I say with respect to C, incidentally, in this case, C is fixed. Sometimes it's possible C may be in motion, in which case you have to take relative to C. So, I have written omega with respect to C. Maybe omega of O with respect to C. More appropriate. You got the point? And here the velocity is 0. Therefore, V minus of this 0. Then I get this is nothing but V. The perpendicular distance is R. So you got it as V by R. And we know that this is nothing but your d theta by dt. D theta by dt. Now look at this. If I ask you what is angular velocity of O with respect to A, what is this? I join these two. Let me tell you, if I join these two, I take this angle as phi, let this be theta, omega O A, omega with respect to A, this is nothing but d phi by dt. If you can get a relation between phi and theta, you will automatically get the answer. One simple way, look at that. What is phi here? Now, this is R, this is R. This is an isosceles triangle. Alright? Therefore, the opposite sides must have same angle. So, this is also phi. And what is this angle? pi minus 2 pi. Therefore, what is theta? 2 phi. So, phi is nothing but theta by 2. So, d theta by 2 by dt or d theta by dt is omega OC. So, omega OA is equal to omega OC by 2. Likewise, you have to work out. I hope you understood this. So, if they ask with reference to any point, sorry, on the circumference, this is how you have to do it. Okay. This is the one point that you should. I'll just try to give you a simple example which you find in almost in all the things. One, see the mods. This is seconds hand. This is minutes hand. This is seconds hand. And hours hand generally is likewise hours hand. What is the angular velocity of seconds hand in a clock? It completes one full circle 2 pi radians and it will take 60 seconds. Therefore, 2 pi by 60 radian per second. Minute hand, it will take exactly 1 hour to complete. Two pi by 60 into 60. And hours hand, it will take 12 hours to complete one. Therefore, by 12 into 60 into 60. Do you know incidentally? Omega of Earth's rotation, it will take 24 hours to complete one. I don't know whether you are aware, its value is something which all of you should remember. 7.29 into 10 raised to minus 5 radian per second. If you work out, you will get that answer. And this, wait, now if I multiply with the 2 and divide with the 2, then I can, how much do you get as far as omega h is concerned? What is omega h? 2 omega e. So these are the standard things that you should remember. Anytime anyone can ask questions based on this. So this is one thing which you have to keep in mind. The other aspect is relative angular velocity if they ask at any time. What you have to do, I'll tell you. For example, you take any point A, B. Let me tell you one simple thing I'll tell you. If this end is moving with V1 and this end is moving with V2, what is the angular velocity of this rod? Suppose if I ask you. So with respect to A, point A, omega, with respect to A, I'll do the perpendicular component to the points joining these two. So the perpendicular distance is L. What is the relative velocity? Both are in the same direction. Therefore, I directly take V1 minus V2 and divide by this. The relative velocity divided by the perpendicular distance between the two, you will get the relative angular velocity. Alright? Alright. Now I'll go give you a few examples. Look at this. Now this is V, this is 2V, this is L. The perpendicular I have given. Therefore, with respect to this point V, minus of minus 2V, so omega is modulus if I take, that is 3V by L. I hope this point is clear to you. Okay? Now, what I do? So far, I have given you perpendicular. Suppose this is V1 and this is theta. And say this is V2 and this is theta. Suppose the situation is given, the perpendicular distance between these two is of course L as usual. What I'll do, I will try to get the perpendicular component, and you know that the parallel is V1 cos theta 1, this is V1 sin theta 1. What about this? V2 cos theta 2, and this is V2 sin theta 2. As we have done before, we have got nothing to do with this parallel. Why? What is the role of this parallel component? The parallel components always try to bring them closer or take them apart. That's how it is. Therefore, I am not interested in how effectively they are approaching each other, how effectively they are going away from each other. I am only interested in looking at what is this? It tries to rotate, right? So as before, because both are in the same direction, I will take the relative velocity divided by perpendicular component, that perpendicular distance. That's how you have to work on. Okay. Now, I'll give you yet another example. Now, this is how it is. V1, say this is V2. Now, as before, this is L, this is theta 1, this is theta 2. So, you have V2 sin theta 2. Here it is V1 sin theta 1. So, you can now easily come out V1 sin theta 1. So it becomes plus V1 sin theta 1 plus V2 sin theta 2 is equal to L. That is how you should get your angular velocity when the information about linear velocities are given to you. Right? Now, with this background, I'll try to close it here. In my next brief lecture, I will try to do some miscellaneous problems. Actually, some of them are not in advanced JEE also, but I'll try to give you a few examples, particularly how to get the radius of curvature, that is number one. Number two, how to get the projectiles on the inclined surface. Now, these things I'll try to cover before I wind up my kinematics completely. Okay? Thank you.